Hello students, in the previous video we have seen some of the properties of an AP, and in this video we are going to discuss a few more properties of AP. When we have terms in arithmetic progression, then the sum of terms which are equidistant from the beginning and the end is constant. So to see this, let's take an example containing simple variables a and d. The first term is a and the common difference is d. So the terms will become a comma a plus d comma a plus 2d comma so on up to a plus n minus 1 into d. This will be the last term. So now let's find the sum of terms which are equidistant from the beginning and the end. So the sum of the first term and the last term equal to first term is a and the last term is a plus n minus 1 into d. So this will become 2a plus n minus 1 into d. Now let's take the sum of second term and the second last term. That means a2 plus a times n minus 1. That will be equal to the second term is a plus d plus the second last term will be a plus n minus 2 into d. This will be equal to 2a plus, when you take d common, we'll have 1 plus n minus 2. That will be equal to 2a plus n minus 1 into d. And when you take the third term and the third last term, it will be a3 plus a n minus 2, which will be equal to, so the third term will be a plus 2d plus the last third term will be a plus n minus 3 into d. This will be equal to 2a plus, when you take d common, it will be 2 plus n minus 3. That will become 2a plus n minus 1 into d, which is again equal to the previous two sums we got. So from this we can prove that the sum of the terms of an AP which are equidistant from the beginning and the end will be always constant. Now let's see one more property of an AP, which will be any term of an AP will be equal to half of the sum of the terms equidistant from the term. So if suppose an is the term, then the terms equidistant from an will be an minus k and an plus k. So the relation between an minus k, an plus k will be that an will be equal to half of the sum of these terms. This can be proved by writing the terms in this formula in the form of first term and the common difference. So an minus k will be equal to a1 plus n minus k minus 1 into d, and an plus k will be equal to a1 plus n plus k minus 1 into d. Now when you add them, an minus k plus an plus k will become a1 plus a1 is 2a1 plus, so this will be d times n minus k minus 1 plus n plus k minus 1. Here minus k and plus k get cancelled. Then this will become 2a1 plus d times 2n minus 2. When you take 2 common from 2n minus 2, this will become 2 times a1 plus n minus 1 into d. We know that a1 plus n minus 1 into 2 is the general representation of the nth term. So this will become 2 times an. So from this we can write that an equal to 1 by 2 into an minus k plus an plus k. This is exactly the same as what is stated in the property. Now let's discuss one more property, that is if a1, a2, a3 so on up to an and b1, b2, b3 so on up to bn are two arithmetic progressions, then a1 plus b1, a2 plus b2, a3 plus b3 and an plus bn. So these will also be an arithmetic progression with common difference d1 and d2, where d1 and d2 are the common difference of the given arithmetic progressions, which are a1, a2, a3 so on up to an and b1, b2, b3, bn so on up to bn. This we can see by taking a simple example. So let's consider that there are three terms in one arithmetic progression. That will become a plus d comma a plus 2d. And let's take one more arithmetic progression. So there are only three terms. So it will be b comma b plus k comma b plus 2k. According to the property, we need to add the respective elements. That means the first element with the first element of the second progression, comma Now the second element a plus d plus b plus k, comma, and the third element which will be a plus 2d plus b plus 2k. Now here we can see that this will become a plus b, comma, a plus b plus d plus k, comma, a plus b plus, taking 2 common, we can write it as d plus k. Now here let's use substitution. So take a plus b equal to c and d plus k equal to t. Then this becomes c comma c plus t comma c plus 2t. Here you can see that this is also an AP with common difference equal to t, and first term is c, that is equal to a plus b, and the common difference equal to d plus k, where d and k are the common difference of the initially taken arithmetic progressions. So these are some of the properties of AP. There are more properties which can be discussed, and we'll be doing that in the next video. Hope you understood. Thank you.